Hi everyone, this weekend I tried out the Plotly graphing library. You may know it from JavaScript, and I tried to figure out how its implementation in R works, and I wrote a small blog post about it. It's not really an introduction, it was more like a trial and error thing, and I tried to figure out how it works. And in any case, on the blog post, you can see a couple of steps, first things I did with Plotly, and I decided to give you a sort of summary of this blog post in this video, where I only show you the steps that I learned and then give you the quick rundown what I learned from trying out Plotly. If you want to see all the things that I did, then feel free to check out the blog post. The link is in the description. And with that being said, let us start. So here you see my R Studio, and I already loaded the library tidyverse and Plotly. So Plotly is the R implementation of the Plotly JavaScript library, with which you can make interactive plots. So I assume that you already know how to work with ggplot. So this syntax you should be familiar for you. If not, feel free to check out my Yards lecture notes, where I also cover ggplot. You can find the link in the description below as well. And so here I really created a very simple plot. I used the MPG, the miles per gallon data set, which comes from ggplot. You have probably seen it already. And I plotted the highway mileage against the city mileage against each other, and I used the colors of the points to associated with the class of the vehicle. Also, I used GM-jitter to make sure that the points do not overlap. See, if I would have used GM point, then everything is on a nice grid and we cannot really see anything, which is why we will use GM-jitter here. As I said, this should be basic stuff. So nothing really magical going on here. And what I want to create now is an interactive plot. So something the user, in this case me, can interact with. So here I can click or do stuff with this picture, but nothing is happening. So to make it interactive, I'm using the Plotly library. And using the Plotly package is really easy. You simply take the initial plot you had, which I saved as a variable p, and then pass it to the command ggplotly, which tries to format or convert a ggplot object to a Plotly object, so to make it an interactive object. So there you go. As you see, the window changed. So here we're looking at the plots tile, which contains the static image. And here the viewer window opened, because Plotly will generate an HTML file basically. So there comes the interactiveness from. Otherwise, with a static plot, there couldn't be interactivity by definition. So let's see what we can do here with this interactive plot. What's so interactive about it? So first of all, we can kind of filter using the filter points using the legend. So for instance, if I only want to look at the compact, mid-size, pickup and subcompact cars in the data set, I will simply click on all the other legend items and they will get taken out immediately. Similarly, if I only want to look at the pickups, for instance, I could double click on that and then you will see, okay, here I only see the pickups. This is quite nice because it helps me to helps the reader to figure stuff out on his or her own by simply, well, clicking stuff. Also, there's a lot of things going on here. Even though we jitter, there's still a lot of overlap, and I might want to make this more, want to see more clearly what's going on. So with the plot being interactive, I can just drag a rectangle around it and zoom in to this specific rectangle, and then I can look at the points more closely. Also notice that if I drag the cursor across a point, it will always show me the specific values that correspond to these points. So this is quite nice, and it can be really helpful to have something interactive in your Shiny app, for example, which is why I'm trying to learn interactive plots. And I started this with Plotly. And one thing that bothers me here is that this bar here, the options bar from the Plotly, will always overlap my legend description. So the class here corresponds to this legend here, and it will always overlap. So this is annoying. With ggplot, we know we can simply move the legend by using theme legend position. And here I want to bring it to the bottom. Let's do that. So this is what it would look like in ggplot, and now let's try to make this interactive again. Let's convert this new variable. And here we see this didn't really work out like we wanted it to. So for some reason the theme option really didn't do anything. And what you could wonder about is whether theme doesn't work at all, or if it's maybe just this legend, or if it's only some things that go wrong with this conversion. So let's try to apply theme light. Maybe this will, at least some of the parts there will get changed. So again, with ggplot, if I run this, it is not running. My R is doing weird stuff. Okay, now it works. So here, this is the static picture again. This is how theme light looks. It doesn't have this gray background as the default ggplot. Let's see what happens if we convert that. So there we see that things actually changed. So some changes do take place. And in order to change everything that didn't change with the initial ggplot, we will have to take this plotly object and manually adjust it later on. So now that we've converted it, we can try to change its properties here. So maybe I can move this legend now in the second step. So actually we only need to pass this to the layout function. It's also, as you see, a plotly function that will take all the arguments that are related to the layout. So let's look at the documentation here. And as you can see, the documentation isn't really that great. I mean, I learned it, I tried to figure out this weekend how Plotly works, and all I got was this. So in any case, here is a hyperlink we can follow to see what arguments we can use. But in any case, there's not really an example of how this function works, which is a shame because I think it would be helpful. But for now, let's try to figure it out anyway. So this is the page that loads, or more precisely, I don't know, it's exactly this. So this is the page that loads, the layout page, and here we see that there's basically the whole documentation of things that can get adjusted. And so let's see if we search for legend here. This will not bring me to where I wanted. I wanted to simply go here. So if you scroll through this table of content manually, you will see that at some point you will get to legend. And if we want to change stuff like moving it to the bottom, we will have to go across all of this and figure out if there is something that helps us do it. In this case, we will find down below here X and Y, which will determine the position of this legend. Initially, I tried X anchor and Y anchor because when I looked at the possible values, it already had top, middle, bottom, left, center, and right there. So I figured it might be the same as with ggplot. Just put in legend position or X anchor, Y anchor bottom, and then it will work out. But this didn't work in any case. So now I know I will have to use X and Y. So let's try to adjust that. Let's try to adjust X and Y here. And the thing we will have to figure out is how does this layout function want to have this argument here. So if I want to change the layout legend, I will have to be careful that I change this stuff here. So I see that all of this is below legend, and this is the parent of legend is layout. And basically what I learned is that the function layout basically already goes into the parent layout, and from there we can go even deeper down this I don't know, tree, I would say, and change the options. So the next step would be to go into legend, and then from there on I will have to check if the next step is X, and actually it is X and Y. So here we can then give a list of arguments we want to change here. So X should be, well, what should it be? X can be a number between -2 and 3. So my guess is that from 0 to 1 is the original window. So this part here, and then everything outside of that is, well, also outside of that. So here we want to move it X close to 0, maybe a bit larger than 0, and Y below 0. So let's try X is 0.1 and Y is equal to -0.2. Let's see what happens there. And as you can see, this already moved our legend, and this is quite nice now that we figured out how it works. But again, from the help you might be a little bit lost, but I guess once you know that this syntax works like this, you know how all of these layout functions work. So let's see if we can figure out how to make this look like the ggplot. The ggplot, I don't have a theme bottom anymore, or legend position bottom anymore. So I want to have it horizontally aligned. So let's look at the documentation again, and what I've already seen up here is that there is orientation here. So again, it's the parent, its parent is layout legend, so I can simply add it to my previous list. So orientation is equal to H. And there you go. So now it looks a bit nicer. We could have tweaked this a bit more to not move it to the right that much, and we do not even need to go down below like this. And this way apparently we can change the layout options and adjust it according to our wishes. Alright, so actually if we had, maybe a funny thing, if we had not tried to tweak with this manually, setting orientation equal to H would have already sufficed. But we will have to be careful though, because sometimes this values would get overplotted, but otherwise I think this already looks quite nice without having to tweak the X and Y values manually. And if we know that there are values, we can move around the picture, but still be aware that your legend could potentially overplot your points. With that being said, now that we know how this works, how this layout function works, let's try to change a couple of more things. Let's try to change the legend box even further. So here, so far, we have only changed the orientation, but we might want to have a border around it, around the legend box. So I know from the documentation that there is this argument border width, so I can set it to the amount of pixels, and it doesn't look like it's changed anything. It probably needs a border color before you can see anything. Border color, let's make this red. I don't know, let's just try to do something. If it doesn't have to be pretty, the point is trying to figure out how to change stuff. The background color is BG color, BG as in background. So also pretty straightforward. I guess you will just have to scroll your way through the documentation and see what you can change. And now let's do something a bit more tricky. Let's try to change the font. In the documentation, you will see that there is somewhere, I mean, this is font, but it's not the right font. Here, parent is layout legend, and it has argument font. Okay, so I want to change the font, and font itself has a couple of attributes again. So here, if I want to change font, its parent is layout legend, so I will need to change font in here. So if I want to change font, I will have to write within the legend list, I will have to write font, and then to pass the arguments to font, I will have to give a list again of with the attributes in this list. So for instance, if I want to change the color of the font to white, then I will have to nest another list in here and pass the color attribute this way. We could also make it a bit larger if we wish, or change it to some, I don't know, the family to overpass, whatever that is, we will find out in a second. Okay, so I guess this is the overpass font style. So this is how we change it. And this nesting of lists appears over and over again. So for instance, if I want to change the title, as I said, we've already seen title. Exactly, notice this layout, where is legend? Here, if we want to change the legend title, we can, again, the parent here is layout legend, so we can write title immediately into the layout function here. And then if we want to change stuff, we will have to pass it to a list. And now if I want to also change the font of the legend title, I will have to basically do the same thing as before. I will have to write font and then nest another list, and then I could basically just copy and paste this here. Also, we will need to make sure that it appears, so it should be displayed at the top. And the text, I guess, needs to be manually chosen as well. So the text is class, I don't know, legend. Let's call it class legend, whatever. The point is just to show you where things appear. And yeah, this is how it works. This is how the layout function works. So yeah, I guess these are the first steps. We can still have the interactivity with this Plotly object. We can still zoom and all. It's just that we have learned to change the appearance a bit. So I wanted to make sure that I can use Plotly kind of on its own. I do not want to use, I mean, I like to use ggplot, but I don't want to use it and then convert it to something I want to use in the end. Maybe I should be able to also use Plotly on its own. So let's try to recreate this plot without having to rely on ggplot doing the actual plotting for us. And yeah, so let's try to do this. So again, we want to start with the same data set, and now we want to use the plotly command. So from plotly, from the package plotly, you get the plotly underscore ly command, which you can use. And the plotly R package tries to implement a similar grammar of graphic, or I think it's actually one and the same grammar of graphics approach as ggplot2 does. So as with ggplot, we take the data set, pass it to the initial plotting function. In ggplot's case, it's ggplot. In plotly's case, it's plot_ly. And then we can add new layers of geometrical objects to it. In Plotly, we use the pipe instead of the plus from ggplot, so we pass it along to the next layer. And apparently a lot of these layers, or I think all of these layers, start with add as opposed to gm with ggplot. So with Plotly it's add, and then we want to add markers. This is the basic, from what I could gather, the analog to gm point. It's add markers. So now we need to specify the, as you can see here, we need to specify, where's markers there? X, Y, and Z. Oh, we could make it three-dimensional. I don't want to make it three-dimensional, so I will just specify X and Y, and also I will use color as we did before. Okay, so we want to use highway mileage, Y is the city mileage, and the color is the class. This is what we want to do. So let's try this. It should not work. I don't know why the console is not opening. It's complaining that the object, well, this object HWY is not found. And basically the thing that goes wrong here is that in this on this line we are missing the AES, the aesthetic command from ggplot. Of course, it's not the same thing, but the idea behind it is the same. We didn't give a mapping, so we didn't tell Plotly here that, you know what, this refers to a variable within your data set. So we need to make sure of that. This is basically what we do when we add the aesthetic in ggplot. So in Plotly, this is done with a tilde. So once we fix that, it should work out fine. Now stuff is happening. So that's good, I guess. Yeah, what a comment. I wanted to point out that, of course, you do not necessarily need to make it a mapping. You could technically, I don't know why one would do it, but just to illustrate, you could also pass the vector that contains the x values directly. Again, it's very similar to the grammar of graphic approach ggplot implemented. So here, if you already know ggplot, it shouldn't be too hard to figure this out. Now we see that as before, when I illustrated gm point instead of gm jitter, we have everything lying on a grid, and for some reason I couldn't find add jitter or something else. Maybe there is stuff like this to add a layer of jittered points, or jittered markers as it would be called then, I guess. But as I couldn't find it, we'll have to do it manually. So let's declare variables to jitter the variables by. So we will have to have a reference for both city mileage and highway mileage, and then we can transform the data ourselves. So let's just mutate the variables manually by adding random noise to it as GM jitter does it. I don't know what the defaults for GM jitter are, how much jittering it applies to which variable. Here I just took some values. It doesn't really matter for our purposes. I just wanted to see the jitter here. So we add random noise to it, and then we make sure that it can jitter equally into both directions. Jitter and so here we have random uniform noise going from negative jitter highway to positive jitter highway. And the same thing we do for the city mileage. Okay, I think I covered everything. Now we can instead use the jittered points. So this looks like it was jittered, looks a bit more spread out. So I guess it worked like we wanted to. For good measure, let's make it reproducible by setting the seed. And now we want to see how we can change the basically the alpha value from GM jitter here. We want to replicate our original plot, so let's see how that works. With add marker, we could simply, same as with ggplot, add the specific layer specific values in there into the layer. So here we could say we still have to abide the attributes, so we will have to look at the documentation again, and somewhere we will find scatter here, and in there we should be able to add marker. Maybe we'll find it here, maybe I found it in the I found it here in the documentation. So with the mark, we can change the markers here by passing marker and a list for it to the dot 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 operator in here. So this basically accepts all the stuff we can find in the original documentation again. So if I want to change the marker, I can pass it a list. I can pass a list to it. Let's make it large points. Make sure that they are somewhat transparent. And I also, as with this plot, I want to have a line around the plot. So I want to have a border. We can customize this with line, but this again has a few attributes on its own, so we'll need a list in a list again. So let's make it black, and the width should be 2. So there you go. This looks more like the plot we had originally. So one thing that I find interesting with Plotly is that we do not necessarily need to do the styling within the add markers layer. We can also, as we did before with our converted Plotly object, after the conversion it is a Plotly object, and then we passed it to layout to change the layout. We can do the same thing here, just without the conversion, because we have a Plotly object from the get-go. So this is a Plotly object, and now we pass it to some function to change stuff. So here we pass it simply to the style function because we want to change the style. So for some reason I find that kind of interesting that we can change all these attributes later on in a separate layer. But in any case, as you can see, it works out just fine. This way we can have the, so to speak, the data in the first layer, and the styling later on we can have in the later layer. I find this kind of cool, so this is why I showed you this. Okay, and if we wish, we could also add the same layout function we did before and pass it to here. It's as before, it is a Plotly, we have a Plotly object and we pass it to the layout function, so everything should work out fine. And if we render it, then you will notice that for some reason the legend is now at the bottom. But if we, when we were executing this command, the class legend here is on top here and it just looks different. And honestly, I have no idea why this is happening. My guess would be that within the conversion by ggplotly, some default values are changed, so the behavior is different, but this is just a guess. But what is also interesting is that ggplotly changes some of the defaults and we haven't noticed it yet. So for instance, if we look at our plot here, so let me just get rid of the layout again, because yeah, it's a bit ugly. I mean, we made it ugly, but we don't really care about the legend now. I just wanted to illustrate the layout function again. But what you see here is that if I hover over the points, then this tooltip, the information that is displayed, does not look like our converted plot. So when I converted this here, so our ggplot object to a plotly object, then we can immediately see, well, there's a lot of information there. There's already the variable names and the class, and also there's only one box, and there's nothing on outside of the box. So here, for instance, you can see that outside of the box there is the class label again. So here, this is an example where the default values were changed, obviously by the conversion, and I suspect that the same thing is happening, or obviously it's happening, but I think this also results in that the layout function behaves a bit differently, or the arguments that were tweaked result in a different legend. In any case, it doesn't really matter for our purposes. You will just take the plot you have and then adjust it until you're satisfied with it. Here I simply want to end this video like I ended my blog post, by simply making sure that the information that is displayed is looks similar to the converted object. So let's change the hover template, which we can simply set to, we will have to give the text manually, so our X value is HWY, and we can access the data via this syntax here, and we want to put X in here, and we format it as a floating point number with 2 decimals. Then we want to have a line break, we indicate this by \n. Then we want to have city mileage, same thing to access the Y values. And if we apply this, you can see that now our information looks a bit better, but you still see that in this case SUV, or more generally the class label, is still outside of this. And this is what the documentation refers of the hover template refers to as the secondary box. So here you can see that the color is mapped to is displayed in the secondary box, but we do not want to have the secondary box. So to get rid of the secondary box, you simply add this here. Everything that is between that is part of the secondary box, and if we have nothing between it, the secondary box doesn't exist. Pretty simple, basically. So now, if we do this, the class label is gone altogether, but at least we got rid of the secondary box. Now to get to the class labels again, I simply mapped the class to the text attribute again. And now you can see, well, text isn't used here, but we can add it the same way we did before. So class is text, and now we should be able to see it. So there's that. Now we have seen another way we can tweak with this interactive plot. And yeah, that's all I wanted to show. I hope you enjoyed this video. In the end, it was supposed to be really fast and really short video, but I think, yeah, it's 35 minutes almost again. Sorry about that, but I hope that you got some value out of that, and you are now able to do your first steps in Plotly. And with that being said, I will see you then next time. Bye.